big odds, my friends. He's got helium-4, I think. He thinks so. Fritz Will, one of the most careful men I have ever met as far as an experimentalist, a man who put his entire reputation on the line when he left the GE Schenectady research labs to head the National Cold Fusion Institute. Yes, it closed down due to the politics and the lack of money and everything else, but at the last international conference, and now published in the Journal of Electroanalytical Chemistry in '93, is this conclusion that reproducible tritium can occur. That is enough, should be enough to make everyone take notice. A careful fellow like Fritz Will, precise man, impeccable ethics, impeccable standards. He's willing to put his name on it. And he makes probability statements, too, that it just cannot be a mistake. Okay? It just can't be, as far as he's concerned. But you can look at the paper yourself and see what he says. We have Tuggle and Clater at Los Alamos with reproducible tritium. Many types of tritium measurements have been done at Los Alamos. Our nuclear weapons facility generating tritium, and the director not taking note of this. Interesting politics. Fascinating. Then we have this incredible paper of Reifenschweiler, which didn't even occur during cold fusion. It occurred 30 years ago. But of course, he heard of cold fusion. He was at the Philips lab in Holland. And he found, to his astonishment, but he knew at the time there was something weird going on, but he was too busy to publish it at the time, and probably no one would have allowed it anyway. But he found that temperature changes in a titanium powder inside a Geiger tube, which was being tested for Geiger tube applications. As the temperature went up, first of all, the counts out were steady as they should be. Temperature should not affect radioactivity, correct, gentlemen and ladies? Well, it did. It declined. And here he also measured very carefully the pressure of tritium to test whether, was it coming out, was it being gotten rid of, and could that explain the decline in the tritium counts in the Geiger counter? And the answer was no, because the tritium pressure was the same until it got very high, and then for some reason the counts went up again. Unbelievable phenomena occurring. That is in Physics Letters A, a very mainstream science publication. When this first came out, some of my colleagues said, well, every lab on the planet should be doing that experiment, that the heat, would change radioactivity. Well, I haven't heard any attempts at replicating it because, of course, they know it can't happen. That's why they're not trying to replicate it. But there are people who are pursuing it nonetheless, looking at the background of it and so forth. Here's a wonderful result from the proceedings of the 4th International Conference, accidental, by Makubri at SRI International, where his cooling system got stopped up briefly, and then what happened was he got this tremendous 368 kilojoule heat burst. And it went up. Look at the temperature rise. And Makubri's calorimeter is so good that little fluctuations here are real, are measurable. This is like a redwood tree sticking out of the forest of the noise. I mean, there's just no way that this is not true. This is true. This did happen. And that suggests what Martin Fleischmann has said, that heat will be a sort of a positive control system coefficient to accelerate the reaction. Piantelli and company have this nickel system with just pure hydrogen gas, not even deuterium gas. And they get a very hot cathode. I think they have, I suspect they have some secret conditioning mechanisms for it, maybe even relating to magnetic fields. I don't know until they fully publish. Most recently, we hear from our inside contacts at the University of Siena, Piantelli has found 50 keV gamma rays off the nickel, and he is going to be publishing on that. He's putting a paper together. In essence, this is their curve. They have a calibration curve here, and then they trigger the process somehow, and what you see is coming down here, heater input power and the nickel temperature. There's for the same input power, I'm getting lost here. For the same input power, they achieve the same temperature. No, for a different input power, they're able to achieve the same temperature, so that tells you the excess power. And the excess power is indefinitely, it just goes. You know, this wattage just seems to go and go, and they went for 3 months and it didn't stop. And then we have the ceramic proton conductors of Mizuno, and above the calibration line, this is the input power, minute input of electricity, absolutely minute input, and the output is always above the line. This is the calibration line. And George Miley, a hot fusion scientist at the University of Illinois, does this. He talks about that in the proceedings of the Fourth International Conference, but also this wonderful, wonderful thing that has just happened. A select peer-reviewed set of papers from the proceedings of the Fourth International Conference is in Fusion Technology Supplement. And Miley put his own paper in there, and rightly so, because he's getting several kilowatts per cubic centimeter in a thin film approach using sandwich layers of various kinds. So he's got a little cold fusion reactor, and he continues to be a hot fusion person himself.